Welcome to Decoding Complexities, and I'm Pradeep. Let's decode what matrix inverse is in this video. If I give you this equation 5x is equal to 10, we will easily solve this equation and we just divide 10 with 5, which gives us the result x. In the world of machine learning, the problems won't be straightforward like what we have just seen, which will be more like this: ax equal to b. Here, A is a matrix of our data, or in a machine learning terminology, we can say input features, and B is a vector with the results that we want, or we can say it as a labels, and X is a vector that we need to find that contains the model parameters. And how do we solve for model parameters here? Do we divide vector B with matrix A? No, we don't. Instead of dividing, we multiply the vector B with inverse of the matrix A. One thing we need to understand that inverse of a matrix is not always possible. We'll see that in a bit. So what is a matrix inverse? We write inverse of a matrix A superscript -1. And one simple rule is when we multiply matrix A with its inverse, it gives us an identity matrix I. In other terms, we can say inverse of a matrix is the one that perfectly cancels out the original matrix. What I mean by that is, if I multiply matrix A with its inverse, the resultant matrix would be I, which is an identity matrix. And identity matrix is a matrix that contains 1 in its main diagonal and zeros in all other positions. So how do we calculate matrix inverse? There are 3 steps involved in this process. The first step is to calculate the determinant of a matrix, and the second step is to swap the diagonal elements and negate others. Swapping the diagonal element means the top left element of the diagonal goes to the bottom right, and bottom right element of the diagonal goes to the top right. And the third step is to divide 1 with the determinant and multiply the result with a swapped matrix. Let's take an example of a 2 by 2 matrix which contains A and B in the first row, C and D in the second row. So first we need to calculate the determinant, which is AD minus BC. And the next step is to swap the diagonal elements and negate the others, which gives us the resulting matrix D and minus B in the first row, minus C and A in the second row. And then we have to divide 1 with the determinant of a matrix, which gives us 1 by AD minus BC, and multiply this with the resulting matrix, which is D minus B and minus C A. Let's try this with a real example where we take our matrix A with 3 and 1 in the first row and 5 and 2 in the second row. The first step here is to calculate the determinant of this matrix, which gives us 3 into 2 minus 1 into 5, and the determinant is 1. And the second step is to swap the diagonal elements and negate the others. This gives us the resulting matrix 2 and minus 1 in the first row, minus 5 and 3 in the second row. And the third step is we divide 1 with the determinant, which is 1 in this case, and then multiply the result with the swapped matrix, which gives us 2 and minus 1 in the first row, minus 5 and 3 in the second row. So this is the inverse of the matrix. So let's multiply this matrix with its inverse and see if we get the result as an identity matrix. So we have 3 and 1 in the first row and 2 and minus 5 in the second row. Let's multiply first row of this matrix with the first column of its inverse. 3 into 2 plus 1 into minus 5, which gives us 1. And in the same way, we multiply the first row of this matrix with the second column of this matrix, which is 3 into minus 1 plus 1 into 3, which gives us 0. And the same goes for the second row. So we 5 into 2 minus 2 into 5, which gives us 0, and 5 into minus 1 plus 2 into 3, which gives us 1. So the resultant matrix here is that 1 and 0 in the first row, 0 and 1 is in the second row, which is an identity matrix of size 2 by 2. And this was pretty simple because we took an example of a simple 2 by 2 matrix, but it is not the case when we work with the data in real life. We will have data of higher dimensions, which is difficult to calculate in the process that we have done. So how do we do it in Python? NumPy has its own linear algebra module. Let's take a look at the simple Python code by using the same matrix we just calculated. We define our matrix and call the inverse method from the NumPy's linear algebra module. That's it. It gives us the inverse of a matrix. But remember, in the beginning we said that inverse isn't possible for all the matrices. But how do we identify whether we can calculate an inverse for this matrix or not? The first step is For being able to calculate the inverse, the matrix should be square. And the second thing is that the determinant of the matrix should not be 0. These are the two important points that we need to remember. If the determinant of the matrix is 0, then we will not be able to calculate the inverse of a matrix. And it is very critical point to remember. And a matrix that can't be inverted is called a singular matrix. In real life, when do we encounter singular matrix or a matrix that we couldn't invert? When the input matrix has the redundant features. Let's take an example of a e-commerce data which contains the item details and price of the item in different currencies. Say price in USD, price in INR, price in EUR. So all these three different features which contains the price are highly correlated with each other and could be redundant. So we need to remember to clean the data for redundant features before training any dataset. The matrix inverse is a powerful tool for solving systems of linear equations, but it comes with a critical warning to check on the input features. With that, our foundational toolkit is complete. We have mastered the transpose and we now understand the inverse. We have all the pieces we need to be able to build our first linear regression model completely from scratch. It's a video where all this theory finally becomes a real working tool. You don't absolutely want to miss it. If this video was helpful in understanding matrix inverse and how to calculate a matrix inverse, hitting the like button tells YouTube to share with more people. And make sure you are subscribed with notifications on so you will be notified when we publish our next video where we will build the linear regression model completely from scratch. Thank you for watching and I'll see you in the next one.